All right, so first one, find the area under the curve over the interval. All right, how do we set this up? What do we do? The integral from what to what? Which one?
7.
Okay, 7 should be on the top, 2 should be on the bottom. All right, and then it's just the square root of x, right? Now, here is one thing that I did not tell you, okay? And that's on me, I meant to tell you and I forgot. Say, instead of getting it set up like this, you got it set up like this, all right? What your calculator is gonna give you is, it's gonna give you the negative of whatever this is up here, okay? So, remember, our very last step to all of these is, since we're trying to find the area, if you get a negative answer, what do you do? You just take the absolute value of it. Okay, so what I'm telling you is technically this order doesn't matter as long as you remember this very last step. Okay, all right, and this will happen every single time. If you just switch the order of these, you'll just get the negative of whatever this is up here. Okay, so for the second one, how do we get it set up? Dallas, what do we do for this one? And then we have the equation, right? All right. I'm assuming, based on what I saw you guys do last week, I'm assuming we know how to use the calculators for this. Do you guys have any questions on any of those? All right. Go ahead and copy those two down then. All right, for the first one up there, we need to find the area of the region enclosed by the curves. All right, now for number 3 here, we have our restrictions. What do we need to check for though? Yeah, we need to see if they intersect, right? So how we check and see if they intersect is, because they're both set equal to y, we can set them equal to each other. And then we just have to solve for x. So we're multiplying by x squared here. So we've got a negative x squared equals 2. Multiply by a negative. So x squared equals negative 2. Take the square root. And we're going to get an imaginary number there, right? Okay. Whenever you get an imaginary number, that just means that they will not intersect. Okay. So these don't intersect at all. All right. To get the integral set up for this, what are we going to do here? Integral from what to what? Yeah, -1 to -4. And then what do we do with these two things? What do we do with the two equations? Yeah, we subtract them. All right. And then you throw that in your calculator and then you're good. All right, questions at all there? All right, really those are the steps for every single one of these. You have to check and see if they intersect at all. All right, if they do, then you've got to do an extra one. Okay, if they don't, then you do just what we did here. All right, now at number 4 here, we have two curves. We don't have any restrictions on this one, do we? So what do we have to do to find those restrictions? Somebody besides Ethan. Yep, set them equal to each other. And then we're just solving for x here, right? Now for this, just quick algebra review. It doesn't matter which way you go with this stuff, okay? I would go so that my x squared is positive. So I'm gonna move all this stuff over here. So I'm gonna add the 2x over, subtract 16x, and then add 30 over. What is that? That's 12. All right, and now that equals 0. All right, quadratic formula, you can factor it if you can. This one you can. This turns into x minus 6 and x minus 2. All right, but quadratic formula works for it too. All right, so x equals 2 and 6. Those are our restrictions here. So then we are going, now does it matter which way we go? First one minus the second or second minus the first? The order of that doesn't matter at all. All right, but just remember that at the end, if you do get a negative answer, then you just take the absolute value of it. All right, any questions there at all? Okay, next one. We're gonna do the same thing, right? All right, we do have restrictions here, so chances are it's between -2 and -5, but we do need to see if these intersect in between. All right, so we'll do this one, we won't do number 6 then. All right, so setting these equal to each other to see if they intersect. All right, I'm gonna move these this way. All right, so the 2x's cancel, subtract the 16, and subtract the 28. Set that equals 0, so then x equals, looks like -3. All right, -3 means that, first of all, it's in between our restrictions here. If it fell outside the restrictions, do we care about it then? No, we don't care about it, all right? But since this one does, we are gonna go from -2 to -3, and we're gonna go from -3 to -5. All right, so then we get the rest of this set up. All right, and as you're doing this stuff, if you want to simplify these equations, you absolutely can by combining like terms. And the same thing on the bottom here. Now notice when we take the integral, every single time it is one of the equations minus the other equation. That does not change ever for anything that we do. Okay, and then what we get for each one of these, evaluate these separately. So we get an answer here, and we get an answer here. All right, what do we have to make sure of with those answers? That they're what? Yeah, that they're positive. So technically, we have to take the absolute value of whatever answer is in there. Okay, and then what do we do with those two answers? We're going to add them every single time. Okay, so inside the integrals, we always subtract. Okay, when we try and find the area of the two integrals, we're going to add the two of them together. All right, and that's always the case. That process does not change at all. All right, any questions for me? All right, so I was nice and quick today. I did review with you guys, like I said, to make sure that we are ready for